Hello there YouTubers, I'm your host SuperDavo001 and welcome to my new tutorial series on how to render fractals, in particular the Mandelbrot set. Now, before we start, why would you want to render fractals? A couple of reasons mainly. Number one, they are just beautiful. Just look at the images, they're just beautiful to look at. And second of all, they can be very fun programs to write. But before we can start learning how to render fractals, first we need to learn how to actually output images and save them as actual files. So, let's begin. And so here we are, I've created a brand new project. And this project, it's got a few things in it already. First of all, I included IOStream and stdlib, just as standard. I then added in usually using namespace. Don't really need to explain that. I will need to explain these. These are the two headers that these two headers always start the bitmap file. Any bitmap file starts with a BMP header followed by a BMP info header. And the contents, you may as well just copy them out rather than trying to understand them. You don't need to understand what all of them do. Some of them you just type things in, you just have to. Like this one, these BF reserve ones, I don't know what they're for. It just literally must be 0. Don't ask, don't know. But yeah, and this Pragma pack thing, that's some sort of compatibility thing. It's the way that it packs in the bytes just to make things fit. And I'm also going to have to, oops, if I can type. Probably ought to include FStream now because it should be quite obvious that we're going to be working with file systems. So, let's begin. Right. Hang on, let me just, there. So, first of all, we're going to need some stuff. May as well create a structure for the colour. Now the way we're going to handle these internally is using 3 floats. One float handles the red, one float handles the green, one float handles the blue. Simple enough. I apologise for the microphone, I swear. Hang on. If I'm right, it keeps running into the wire thing, which is a bit of a menace. Let's just create a constructor. There we go. Constructors are always handy. So, what we're going to need now is we need some stuff about the image. We may as well know the width of the image. Well, may as well know the height of the image. And let's just set these to values now. What should we set it to? 1280 and 720. Let's just have them as values. We also need a array of colors. This is effectively a 2D bitmap thing, but it's stored in one direction, and it's going to be length of width times height. That's going to be the length of the array. So now we're going to need to actually come up with something for this image. But first of all, if I just move this hello world, I've just added in the system color OA command, which turns the command prompt green. If I just add in the hello world back, compile. Apologies for that. Oh gosh. Yep, here we go, hello world. It went wrong on me because my record button's the same as my compile button. That's going to take some getting used to. I've changed it to F11 now, so compile's F10, thing's F11, so hopefully that won't cause me any more problems. But yes, so I've turned the command prompt green. I like it like that. You don't have to do that. But I did that using this command. And that's where the stdlib comes in handy. So, right, now we need to actually start working on the image stuff, so I'll remove that. So set it to a new array. It's a 1D array that stores 2-dimensional data. You can get the 2-dimensional point from the 1D array. And now let's let's create something. No. No. Gosh, I can't seem to type today. So, double for statements. This is probably worth knowing. If you want to get the if you got a y coordinate and an x coordinate of a pixel in a 2D array, in a 2D thing, then if you want to know the one-dimensional coordinate of the point, if you want to know the one-dimensional ID in the array of the point, then it's going to be y times width plus x. It's essentially the number of rows that we've already covered multiplied by the length of the row plus how far we are into the next row. So when we're setting the image color, that's how we're going to do it. Now, how should we? Now we need to create some kind of interesting color set. Keep touching the microphone. We need some kind of interesting color set. So, because we could just do this as a black and white image, but let's make it a color gradient just to be more interesting. So, what I'm thinking of doing is as you go right in the image, it goes from no red to all red. As you go down in the image, it goes from no green to all green, and then blue. Let's have blue just be 1. So the colour is going to be. So this is going to be our colour. Apologies to any Americans. I know I'm spelling it English. That's the real spelling, and you know it. So it's going to be x over and 1. As I say, at this point, well, I'm not sure if I've already said it, the internal colour system that I'm going to use is 1's going to be maximum brightness, 0's going to be minimum. So 0's black, 1's full colour, basically. It's going to have to be converted from 0 to 1 to 0 to 255 when it's actually saved, but that's not a problem for now. Oh yeah, it's called image. So we set it to that colour. So that's easy enough. We've now got an image to actually save. So we're going to need a new function to save the image, and what's it going to take? It's going to, so I've got the width and the height outside already. Got the file path. What else do we need? Do we need anything else? No, it's already got access to everything else. So, save image to that file path. I think I'll do it this way. Open the output file stream. Now I'm going to have to use my phone as a slight cheat sheet here, because I can't remember everything. So the next thing we're going to need is, so now we're going to have to deal with these headers. So this is the bitmap header. This is the first thing that it's going to read in all of this. So when it opens a file, when the program opens a file, it sees it's got the BMP extension. It looks at this first of all. It opens it and looks at this. Then it opens the next bit. Then it uses that to know how much it's got to load in after that from the actual image. And the image is just stored as an array of bytes, where it's 1 byte per channel, per color channel. So red's going to be a byte, green's going to be a byte, and blue's going to be a byte. Anyway, let's begin setting some header values. Actually, first let's just may as well create that just ready. So I've got an info header. So first element's this BF type, which is always equal to OX4D42. Now, what is that and why is that there? That's because if you translate it, it actually, I think it's in one of the text things, it equals BM. So basically, it's a little check that the thing has. So if the file starts with BM, then it's a good sign that it's a bitmap. If you load up a bitmap in Notepad or something like that, you'll see that. So next one is BF size, which equals the size of the bitmap header plus size of the info header plus, now this is the size of, if you look, this is the size of the bitmap file in bytes. So you've got the size of the bitmap header in bytes, the size of the bitmap info header in bytes, and then you also have to add in 3, because it's 3 bytes for 3 channels, which is 1 pixel. Multiply that by the width, multiply it by the height. It's effectively 3 bytes per pixel, because it's 1 byte for red, 1 byte for green, 1 byte for blue. So 3 bytes per pixel multiplied by the number of pixels. Then BF off bits. This thing is the offset from the start. Wow, why do I keep... This thing's the offset from the start of the file. So basically, how far along the file do you have to go before you can start loading images? And that's just gonna be these two. It's the size of the 2 headers. Then header.bf reserved 1 equals 0. Same for reserved 2. I still don't get it. There are some really weird redundant things in bitmap files. Why did they just create this variable and why did they just waste 2 variables just to set them to 0? No idea. Now we get onto the info header. How many of these are we going to need? I think that should be right. So number of bits per pixel. This one, which is 24, 3 bytes, 3 channels. BI color important equals 0. This is, I can't remember what BI color important was. I'm not sure if that's to do with the paletting thing, which you can also do with bitmaps. Instead of storing them as a straight array of colors, you store them as an array of addresses, and the addresses basically linked to colors. So if you got an image with very few colors, that's an efficient way of storing it. Something like that. We don't need to worry about that. Yeah, this is to do with that sort of stuff. That one, just set it to 0. Number of colors used, something. BI compression equals, I'm pretty sure this is equal to 0. Technically it equals, in the Windows thing it equals BI underscore RGB. That's supposed to be B. Basically says that you're storing it as a straight RGB image. But I think that value, which is in the Windows standard library, is actually equal to 0, so don't worry about it anyway. You should probably set that to be RGB, but if you do, then you're going to have to include windows.h, and I'm trying to avoid using windows.h. See if it works. If it doesn't work, then I'll know how to change that. And after that, it's BI height, which equals the height of the image, basically just the height of the image. Need I explain any more? BI planes, you just set that to 1. Don't ask. You just do. BI size equals This one's the size the size of the BMP info header. I'm pretty sure there have been different versions of info headers as time's gone on, so I think by judging the size you can tell which version of the info header it actually is. I think that's why that's there. BI size image, and I don't know why this one's on here, because this is completely redundant, because it is exactly the same as header.bf size. It's the same thing. It's the same variable. Why did they add in this extra byte, well, not even a byte, this extra thing here? I think it's 4 bytes. Just taking up space just to say the same thing twice. It makes no sense. And BI width equals width. That's just the width of the image. That one actually does make more sense. BIX pels per meter, and I get that this is American spelling. This is just based off of the Windows prototype, and those comments aren't mine. I found them on the internet. But this header is based off of the prototype on the internet. They came up with a name, I didn't, basically. So this BIX pixels per meter is basically the number of pixels per meter if you're trying to convert it into real units. We're not, so we don't really care what this value is, but let's just say it's 2000, why not? Equals 2000. You know what? Let's spell it in the English version of properly. Much better. Much better. There we go. So now I've got the header and the info header sorted out. So now we can go back to our outstream. Fout.write. Convert it to a child pointer for the convert the header to a child pointer as you often do with Fout. And then similar job for info header. And then now this bit's a little bit more difficult. Because now we're going to have to output our image data, but we're storing it in terms of 3 floats, and we need to store it in terms of 3 characters. So this is where it gets interesting. So we're going to need 3 unsigned characters. These are going to store the values of our color. So for convenience, we're going to just create a color, which is that. So take the color and put it to C. It just makes it easier to type. So R equals convert to an integer of the floor. Do we have floor? I think we need math.h here. Hopefully that should work, otherwise we'll just have to define our own floor function. So where are we? We're here. So the int of the floor of C.B. No. C.R. Idiots. You don't turn the red into the blue. Don't do that. That's not fun. And do basically the same with G and B and G and B. Actually, multiply the... Oh, did I do something? I think I just did something. Oh well. Multiply these by 255 before you floor them as well. As I say, the actual thing, basically in actual bitmap, 255 is white, 0 is black, or whatever, or 255 is maximum color, 0 is minimum. So we're just converting it from our own system of 0 to 1 into this system of 0 to 255, which not too bad. So now that we've got the R, the G and the B, we now this is where it's a little bit interesting. So char pointer, and we do B first. Now I know that the size is 1, don't worry about it, but it's easier just to write size of. Now here we actually do things in the opposite order. Plot twist. Colours are actually stored BGR. Now why is that? I'm not sure, it just is. But yeah, everyone uses RGB and then they just convert it to BGR at the last possible moment. Still don't get it. So now file.close, close the output stream, and we're done. So now we may as well save image, and we save the image to a file path which we're just going to have to come up with. testimage.bmp. Just for fun. So, okay. I just thought I'd add them in. Typical me. Okay, that BF off bits, that's actually B off bits, just because they like to be confusing like that. Oh. Oh yeah, this thing. You also need a default constructor if you're going to be working with an array. And it helps if you don't bracket. It helps if you brace it rather than doing that. Let's just set them to 0. There we go. Now if I run the program, apologies for it not showing in there, it's now done. Where am I? I'm in a video folder, which is very meta type thing. Tutorial 1, test image. Open it with photo viewer. Yes! And it worked. We now have an image. Congratulations, we have saved our own image. Now just to test what I was talking about earlier, if I open with hang on. Programs, other programs. Let's do it with Notepad++. Much better than Notepad. Yep, so you've got all this gibberish. All this gibberish in binary. But if you go back up, see those first two characters? BM. If you did that for any bitmap, that would hold true. And similar things happen with other formats as well. But yeah, so if you want, you can, now that you know how to save images, and now that you've also got a for statement over here, you can render whatever images you want. So now that we've made it easier to actually save an output image, next challenge is going to be to render the fractal and actually make that our image. But before you can render the fractal, we're going to have to understand the maths behind it, which it's nowhere near as bad as people might think. It's got imaginary numbers in, but it's nothing too horrible. So thanks for watching, everyone. I hope you enjoyed this video. I hope you learned some stuff about rendering images, and eventually we'll be learning about rendering fractals. Hopefully two tutorials from now we'll be actually rendering our fractal image, so that'll be cool. So thanks for watching. Don't forget to subscribe for that, and I'm still working on my OpenGL tutorials. I know I haven't worked on them in about 2 years, but I'll come back to them. It's just I've got really interested in fractals and stuff, and I really want to make tutorials on them, so I thought I'd just put that a bit further forward and just get on with that. So Yeah, thanks for watching. I'll see you next time. So in this series, I'm going to be showing you how to use OpenGL. So this is a program I made earlier, just so you know. Hold on, let me just there. It's just now it'll run it properly, but anyway, this is a program that I've made by myself before, and I'm going to be showing you how to make this.